Welcome to this video called Boolean Values, a companion piece to an introduction to STEM programming with Python by James M. Reneau, Ph.D. This goes along with Chapter 6. The best way to use this video is to open up Python and to try the examples in the code and in the presentation. If you don't understand the example, don't move on to the next slide. Modify them, play with them, and try to understand them before you move on. To get started in our discussion of Boolean and Boolean values and Boolean variables, I just wanted to bring up a definition of Boolean according to the dictionary. I like the second definition better. It's a data type or a variable in a programming language that can only have two values, true and false. We manipulate those values using the Boolean operators and, or, and not. Boolean was originally named for the mathematician Boole, B-O-O-L, who defined this way of thinking and this mathematical type back in the 1800s, back in the late 1800s specifically. Boolean values have two distinct values. Either they're true or they're false. Or we'll also use the number 1 or the number 0 to represent Boolean values in some of our computer programs. So remember, a Boolean value is true or 1, or false or 0. With Boolean values, there are three basic operations: the operation of and, the operation of or, and the operation of not. I'm going to talk about each of these operators in a little bit more detail. And is true if both values are true, this and this. If either or both values are false, the result of an and is false. So you can think that and is, if they are both true, it's true. Otherwise, it's false. We can think of and as binary multiplication, or Boolean, I'm sorry, not binary. Binary is way different than Boolean. We can think of and as Boolean multiplication. A 1 times a 1 is a 1, a 1 times a 0 is a 0, and a 0 times 0 is 0. Or we can think of as Boolean addition, or 1 plus 1 is 1. Now, you'd think, well, 1 plus 1 is 2, but we're in the world of true and false only. We're not in binary, we're not in decimal, we're in Boolean world. So in Boolean, 1 plus 1 is 1, 1 plus 0, 1 or 0 is 1, 0 or 1 is 1, and 0 or 0 is 0. So or can be stated logically in English as if either or both of the values are true, the answer is true. Otherwise, it's false. The last Boolean operator that we're going to discuss in this introduction is the Boolean operator not. Not is the Boolean equivalent to putting a negative sign in front of a number, or negation. Not 1 is 0, or not true is false, and not false is true. So it just changes the value of the Boolean value. Just like in algebra, we had postulates and theorems that told us how algebraic expressions work. There are 5 postulates that I would like you to be familiar with when you're dealing with Boolean expressions. The first is the postulate of closure. What closure says that you can replace an element with an equation for simplification purposes. So x plus y can be substituted into, or a plus b can be put in where there's an x, as long as you use parentheses around it. If x is an element, then x plus y is an element. Closure. Identity says that anything plus 0 is itself, and anything times 1 is itself. Well, that kind of makes sense, doesn't it? Anything plus 0 is itself, and anything times 1 is itself. That's the postulate of identity. The postulate of commutative postulate, the commutative law, says that x plus y is the same as y plus x. So true plus false is the same as false plus true. The same goes with multiplication, and x times y, or x and y, is the same as y and x. So the Boolean operators of and or are commutative, that you can switch them around without changing their meaning. The last of the two postulates are the distributive law, that says that we can distribute a value out. For instance, here you can say x times the quantity of y plus z is xy plus xz, and we could just as easily reverse that by factoring out the x from xy and xz and returning to x times the quantity of x plus or y plus z. And you can also see that x plus y times x plus z is equal to x plus yz, and you go, wait a minute, how does that work? Well, x times x, if we go through doing the first outside, inside, last, doing a FOIL defactorization of that equation on the end in the distributive law, we can get x times x, which is x. We get x times z and x times y, and then we get yz as our four terms. And we can then distribute out the x, and we can eventually see that x plus yz is equal to the quantity of x plus y times the quantity of x plus z, as we prove the distributive law. The last postulate is the complement law, that says x plus not x, or true plus false, is true, or false plus true is true. And in multiplication, a value times its not is 0. That little apostrophe there in postulate 5 says not x. So that's like using the not operator. And instead of writing or and, you can see in these postulates I'm using plus and minus to represent plus being or and star being and. Now that you've seen the postulates and understand the Boolean operators of and, or, and not, let's stop and take a look here at what Python considers are Boolean values. Basically, in Python, there's a special value called false that starts with a capital F that represents false. There's another value with a capital T called true that represents true. A 0 is also considered false. An empty string is considered false. An unassigned variable is considered false. An empty list, set, or tuple, or dictionary is considered false. And any other value, like a negative number, a positive number, a string with letters in it, a list with values in it, are considered true in Python as we're doing the Boolean operators that you'll see on the next screen, as we're using the Boolean operators you'll see on the next screen. In Python, we use the word and, we use the word or, and we use the word not as the Boolean operators. So to multiply two Boolean values, use and. To add two Boolean values, use or to create the complement, you use the word not. The order of Boolean operators works very similar to the order of operators in normal mathematical systems. The complement comes first, then parentheses, then multiplication, then addition. So remember that not happens first, parentheses happens second, and or happen third and last. Be sure that if you are creating a very complex Boolean expression, to use parentheses to make sure that the order of operations is clear to you and to your computer program. Here are a few simple examples dealing with the AND operator. You can see that print true and true prints a true, but print true and false and true and all the other combinations of false and true print false. So you can see how Python handles the AND operator. This slide shows the OR operator. True or true is true. True or false is true. False or true is true, and false or false is false. So you can see binary Boolean. You can see Boolean addition at work here. The next slide is the not operator, and you can see that not true is false, and not false is true. So at this point in the video, we've talked about Boolean values, Boolean operators, true and false. But how do we really use that in a programming environment? Well, how we do that is by comparing values using the comparison operators that are shown on the slide right now to return true or false values based upon values that we find in other variables in our programs. The first two comparison operators are equal equal and exclamation point equal. Equal equal tests equality, and exclamation point equal tests inequality, or equal or not equal. Less than and less than or equal tests less than or less than or equal, and the greater than sign and greater than sign followed by an equal test values for greater than or equal. In our sample program of comparing the numbers 33 and 99 stored in the variables b and a respectively, we can see that a is not less than b, that a is not less than or equal to b, that a is not equal to b, and that a is not equal to b. And you can see the results of false, 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 true as we compare the two numbers. You can compare integers and floating points successfully. It doesn't have to be the exact same type. They just have to have the same numeric value. We also can compare strings and string values. You notice that the same program is now storing the letters AB to the variable A and ABCD to the variable B. You can see now, though, that A is less than B. A is less than B because strings are compared left to right. You justify them left to right, and they're compared character by character, alphabetically. Uppercase characters are of a lower value than lowercase letters, and value A, for instance, is a lower value than Z, for instance. So you can see here that A would be, in fact, less than B, that A is less than or equal to B, that A is not equal to B, and again, A is not equal to B based upon the results of our comparison operators. That concludes the video for Chapter 6.